Welcome to Math Minecraft for Computers, episode I34, Register Type 2. Today we're going to learn to build a simplified register in Minecraft, and we will start with the design work in LogicSim. Here we are in LogicSim, and I'm going to show how to build the simplest latch that I know, and this uses 4 NAND gates. So we're going to open up the gates here, and we're going to grab the NAND gate, which is right here. And we're going to set these for 2 inputs right here. And I'm going to copy it 4 times because we will need 4 of these. Something like this. Now, just like last time, we're going to create 2 inputs. One is going to be our data, which will be here. And we're going to have the enable, which I'll put right here. We're going to label this as enable, or write if you wanted to, and this will be the data line. All right, just like last time, we're going to connect the 2 inner ones together like this, and that goes to the enable on these 2 NAND gates, and then I'm going to do the same thing, drag the data to there, and then of course we're going to do the same thing we did last time with an inverter. So we'll grab an inverter out of here. It will face south. We'll put it here, just like this. And then, standard issue, we're going to grab these. And these are going to crisscross as before. So I would like to line these up about right here. But it doesn't give me a lot of room to crisscross to do that. So what I'm going to do is put them about right here. And so this is going to go to the outside input, and the same thing over here. And then of course, since it's a latch, we're going to crisscross these like this. A little bit too far there, back to here. Okay, then we're going to come off of here, and we will put our LED right there. Last thing is we need to hook up our enable this way, like so. Now we are going to simulate this, but there will be a problem in LogicSim that we're going to run into. When I data, as you can see, as usual, I can flip data. I can flip enable, and it's not a problem. When I have data and enable, you see this comes on right here. So we just stored the entry 0. Now, as you saw there, the difference here is I flip data. As long as enable's on, I can change that data all I want. Now I can change it, doesn't matter, let me store a 1 in there, and now data doesn't matter. But when enable is on, I can change this. If you think about this simple gate structure inside of Minecraft, if I simply put a monostable circuit right in this line so that when this pulse came in, it was automatically short, it would automatically turn off, and I wouldn't have a problem. So that is how we're going to build these in Minecraft. Well, let's go back into Minecraft and get busy. Okay, here we go. We're going to go to our previous version of this. And we're going to go in front of it, and we're going to put it right here. Okay, so as you remember, it was a NAND gate. We need to leave a little room because we want our input, let's say our enable input. It's going to have a piece of wire and a block in front of it. And then there will be a dropper and a hopper and the comparator and a repeater here. So we got to make sure we leave room for all of those. So I'm going to go ahead and put the repeater here the way it faces. And that will show us where we can actually come off to the enable. So it could be something like this. So these would then be our 2 NAND gates. NANDs are easy to build. It takes a couple of torches, 1 bit of wire in the center, and that is it. Now, for the other, you'll remember that we have to go over. Now I'm going to make this simple this time and go down 2 like this. And then if I put a torch on the side of this block right there, I automatically get an inverter. going to bring that over, and it's going to connect into here, like so. So now we got that structure. Our data would simply come off of here as usual. We'll bring it all the way back and line it up with this switch. Like so. And then for now, I'm just going to wire this up straight so that we now have an on-off data over here and enable here. We need 2 NAND gates in front of that. A couple of ways we could do it. We are going to come off of this into the NAND gate. I can do it this way. I don't give myself as much room to do the crisscross that way, so I always like to add a space there and get this done. And it's the same thing, being a NAND gate, I need 2 torches on top and that little bit of wire. And of course we will come in over here from the other. So to line that up, once again, I'm going to come off of this particular switch gate right there on that input. And we'll do the same thing, 2, 3. Bit of torch here, a bit of wire, and we're set. And this input will come over from over here. Now the interesting thing is, we are going to come off of this to here. That means for this one to connect, we have to go down or up. And since we've already gone down, I'm going to go down. Now what you have to do to avoid this situation is come down a little earlier, just like this. There we go, under there. That's going to bring it up in this location to here. And so now we have those 2 crossing. You can see that we come from this output into there. And I've got this wrong, sorry about that. This is actually an output, so it comes from here, like this. So there's an output that goes over to that input, and then we come off of here, and we'll put a lamp. And we will get our Q lined up as well. As you can see here, I actually have to come out a little further, so the easiest way to do that is come more, down, up, and we can get rid of these. There we go. Got to have that connected like that, and of course I can replace it. Now I can go down here because I already went down there for that inverter. So this would be our gate if we want to see the other. We're going to put it here. So we have our 2 lamps for Q and Q prime. And now we come back here. We should be able to enable real quick. Set the data on. And you can see over there is Q. The reason why that is Q is because it's the connection off. It depends on how we wire these. If I had wired this one in and brought it over to here, that would be Q. So it depends on how we wire this latch, which one ends up being Q. So as you can see, with data on, and we hit enable, I get Q there. With it off, Q goes off. So this is Q prime on this side. We don't need that, we'll leave it off. And so this then becomes our very simplified latch that we use. Now the problem with this is just like before, if I have enable on and I toggle this, you can see that so does the latch toggle. So to avoid that, we have to go ahead and build our structure here. So for that, I am going to need a dropper. A hopper. Which I'll set those up like this. We put I got bedrock somehow. There's the dropper. Bedrock has no use that I know of except holding you up. The dropper comes and it faces your circuit this way, so that it drops into. You then attach the hopper by holding shift and click. You see the hopper is now attached up to there. And then we need to put and we'll just replace this. comparator right here. So now what the comparator will do will come on when there's some value inside of this hopper, and it will be off when there isn't. So the dropper is going to put one item in it. We'll just put anything we want. We'll put one drop of redstone in there. So when I press this button, the dropper fires into the hopper, which lights this up, and then after a few ticks, that hopper puts it back into the dropper and this turns off. So we can see that pretty quickly here if we watch this wire that's coming out of here. There it is. So it's on. I can make that extremely obvious. We will put a lamp right here with the wire on top. I'm not even sure I need the wire. That should be strongly powered. So you see that light comes on only for a bit every time I click this. Because as a monostable circuit, this circuit wants to be off. So now when I come over here and I turn this on and click this, you can see that it stays. And now I can turn this all I want, and even though the enable is still on, it keeps its value. I have to turn the enable off. And I can flip this all I want, and we finally decide the value. Let's make it a 0. Click that on, and it flips. So this is a much more simplified D-type flip-flop that we'll be using in the future to build an 8-bit register. Short and sweet today. That is it for I34. Keep in mind, we have more coming. We'll be building another register on our bus that we built last time, and we'll be able to transfer values from the bus to the registers and even from register to register. So let's get ready for I35. This was a small, short one to get you ready. A different type of flip-flop that we can use using some Minecraft components, the dropper, the hopper, and the comparator. We've added to the toolbox so that we can do this much smaller way to store data. That is it for I34. Hope you enjoyed. Give me likes, subscribe for more. This is Zimroy, out.